How Spotify really knows you. Ever wonder how Spotify seems to read your mind and suggest that perfect song? Music streaming is huge, and recommendation systems are the key to navigating millions of tracks. But these systems aren't just convenient, they deeply influence what we listen to. Think about your Discover Weekly or Daily Mix. These algorithms shape your taste. They also affect which artist gets heard and how the music industry works. And there's a risk. Are these algorithms creating filter bubbles, limiting our musical horizons? To understand this, we need to dive into the cool science of network analysis. It might sound complex, but it gives us powerful tools to see the hidden structure in music recommendations. Get ready to see music in a whole new way. Let's start with bipartite graphs. It's a fancy term for a simple idea. Imagine users on one side and songs on the other. A connection means a user has that song in their playlist. In order to use Spotify playlist data, you need to use the Spotify Web API and create a public-facing dashboard to get a client ID and client secret. You can then access the Spotipi library. This visualization represents a user song bipartite network, a fundamental structure in network science for modeling interactions between two distinct types of nodes. In this case, shown on the left in the blue is users, and songs on the right in green are connected by edges that represent listening behavior or playlist inclusion. Network projections. Now we can project this. Let's focus on the users. If they share a lot of songs, we connect them. This creates a user-user similarity network, a map of who has similar tastes. This visualization displays a user-user similarity network, which is projected unipartite graph derived from an earlier bipartite user-song network. Here, each node represents a user and each connected user who share similar listening behaviors, quantified through overlapping song interactions. Centrality measures. In this network, some users are more connected. They share tastes with many others. This is degree centrality. These hub users are influential in the network. We also find communities, groups of users with very similar tastes. Algorithms help us detect these clusters. This reveals the underlying structure of musical preferences. This visualization illustrates a song-song similarity network, where each node represents a track and edges connect songs that are frequently co-occurring across user playlists. This projected network was derived from the original bipartite user song graph, enabling us to study relationships among items directly. Nodes are colored based on their community membership, as detected by a community detection algorithm, revealing clusters of related songs that likely share stylistic, thematic, or genre-based similarities. Dense clusters, such as the red group in the center, represent groups of songs that often appear together in user listening histories and may reflect cohesive subgenres or moods. This network view helps us understand how filter bubbles can form. Algorithms might overemphasize connections within communities, limiting exposure to new things. It's a balancing act, personalization versus discovery. Network science gives us a powerful lens to see how music is connected and recommended. It reveals the complex interplay of users' behavior, algorithms, and even the music industry. What do you think? Are music algorithms helping or hindering your discovery? Let's discuss in